Hello everybody, I'm Gleb and today I'm going to tell you about user equipment positioning in 5G networks. Let's get started. Please note, this information is for general purposes only. This is not a technical advice. Please use your own manuals, official guidelines and specifications from your vendor. Let's start with terminology. What's the difference between positioning and localization? Well, positioning, initially term, comes from radio theory, from navigation. It usually means how network can calculate, can determine in vertical, in horizontal dimensions user equipment. Localization, it is initially comes from robotic science, from sensing environment, and it usually means how device can build map using radars, sonars, computer visions, and other techniques. So it is basically about self-driving cars, drones, and all of that kind of things. From wireless networks point of view, this is very interchangeable in my opinion. I would use both of them because in different sources, in articles, in books, you would find these terms very interchangeable. So let's continue. Initially, since GSM networks, positioning was designed to find people in emergency situations. But then with the evolution of mobile networks, more and more use cases became available. For example, now you can collect GPS data from user equipment in your networks and use that data for analytics purposes, for planning optimization. Or you can analyze transport and people flow, or you can make some decisions based on geolocation data from your network. So all of that cases become impossible due to evolution of wireless technology. When we start to think about positioning, we usually imagine satellites. We usually talk about GPS, GLONASS, BeiDou systems. It works very well. We use it on a daily basis. But when it comes to limitations, such as bad weather or indoor coverage or deep forest tunnels, under the bridge, all of that because of GPS signal very weak and it can be lost very easily. So that's why there are other protocols, technologies that can be used for that purposes. Of course, I will cover some of them, but mainly I will be focusing on 4G, 5G positioning techniques in this video. When we hear about 3G, 4G, 5G, we usually imagine throughput, latency, radio access features, core network functions and features. I think we missed that positioning was always be a part of 3GPP standard. Since GSM network, it was possible to locate people using Cell ID, using timing advance or power measurements from their devices. And then it was evolution of that technologies. In 5G, it became fully described, very mature positioning standard because 5G give us more opportunities. This is not only about latency or enhanced mobile broadband services, but also about positioning services. So we can see kind of a convergence of positioning, of geolocation based services and communication services in our net. When it comes to possible accuracy, we can look at this picture from one of the survey. We can see how Cell ID based technologies may give us around 100 of meters accuracy, whereas Wi-Fi or Bluetooth or 4G based technologies may give us around 10 meters accuracy, whereas 5G may give us around 1 meter accuracy, which is comparable with GPS, with satellite-based technologies. That's very interesting. So let's start with Cell ID based solution. This solution is very old since GSM networks. This is very simple and fast method, and we all know that when user equipment in connected mode, we can find them with cell size coverage. Also, we can apply timing advance techniques, and it depends on the standard. We can see how timing advance in meters are different from each standard, and that measurements can be combined with RSSI, RSRP measurements in order to make more narrow the area of uncertainty, in order to make more accurate estimation of user equipment position. Another method is based on time difference of arrival. The thing is that device can measure time difference of arrival from different base stations, measuring special signal, positioning reference signal. It works in a kind of a passive mode when user equipment just locates itself by receiving that signals without sending measurement results to the network. So it supports large number of devices. Of course, it is very good in terms of latency, in terms of how fast such calculation can be done. And another method, the same in uplink. This is relative time of arrival. When user equipment send sounding reference signal to different cells, and base station gives command to configures that sounding reference signals in a special way, then receive that signals from a user equipment device. Measurement is only happens at network side, then measurement results goes to location function in core network. All of that methods, they rely on very good synchronization between base station, and at the same time this is disadvantage of that method. Measuring round-trip time is also possible. In 4G, it was possible to measure round-trip time only from one cell, from servant cell. In 5G, in release 16, it was possible to measure that metric from neighbor stations, from neighbor cells. It works in a kind of a request-response manner when user equipment send sounding reference signal to base station and receive positioning reference signal, multiple base stations. Well, it does not require very strong network synchronization between nodes, but it required calculations from base station side and sending measurements, sending final results to location function in the core net. And as any bidirectional communication requires uplink access, it may lead to increased uplink interference. It may lead to that fact that uplink usually is a bottleneck in terms of coverage. Any problems with interference, it should be taken into account as well. We all know that 5G may use beamforming, massive antenna arrays, millimeter waves, and large band, and all of that very suitable for angular-based methods. The thing is, when we use massive antenna array with multiple antenna elements, it is possible to measure phase difference between each copy of signal received by each antenna element. In case of downlink, user equipment can measure SSB, RSRP, and the strongest adjacent beams. In case of uplink, a GNLB receiver detects uplink beams from user equipment and sends measurements to location function in core network. Of course, such method is also depends on antenna array orientation. So now let's figure out what's the difference between resolution and accuracy. Well, accuracy, this is an ability to divide, to receive in a proper way two signals, which can be very similar. It can be in many domains, in time domain, in frequency, angular domain. And we know that 5G use large bandwidth, which is very good for resolution purposes, and multiple antenna arrays, which also very good for resolution purposes, because it gives us ability to analyze signal in time domain, analyze how each copy of signal have different delays or have different angle of arrivals. So this is very good. Accuracy comes after resolution. Accuracy, it means how well a device can estimate time of arrival or angle of arrival, so receiving signals. This is about very good signal to noise ratio. This is about line of sight operation. And 5G is also here very good because using multiple antenna arrays with beamformings, it is possible to gain SNR even at cell edge, and it means that higher accuracy possible to achieve. Of course, this is obviously that we can combine different methods. If we look at examples from the right side, we can see that we can locate user equipment with cell ID. Then we can apply round-trip time or timing advance measurement in order to narrow uncertainty area, and then we can narrow that area even further. We can apply, for example, angle of arrival methods. So the combination of that methods may give us more accurate, precise calculation. When we're talking about specifications, initially in the first release of 5G in release 50, there was no new positioning techniques described. I think this is because it was rush. Everybody was very hurried. They want to release 5G as fast as it possible. So that's why only in release 16 first 5G based positioning techniques described, such as multiple round-trip time or angular-based techniques. They also give a list of requirements for horizontal accuracy, which is about 3 meters for indoor cases and 10 meters for outdoor cases for 80% of the time. Also, you may find very different lists of and descriptions of use cases. In release 7, it's supposed to achieve centimeter level accuracy with different requirements for availability of that accuracy positioning. So also there are requirements for latency. It means how fast the first estimation can be done. There are also listed multiple use cases for millions of simultaneous of device, IoT and automotive industry. When it comes to release 18 and further 5G advanced specifications, they aim to increase positioning accuracy not only in line of sight, because all previous techniques, they pretty good work in line of sight operations, but when it comes to non-line of sight, it is hard to achieve accuracy. That's why many researchers, many 3GPP groups, they aim to apply machine learning algorithms in addition to signal-based models in order to increase positioning accuracy even in very hard non-line of sight operation. The 5G architecture comes with the possibility to locate device in the network. There are two specific functions in core network. This is location management function and gateway mobile location center. And partially AMF is also responsible for positioning services. For example, let's imagine that to our 5G core network, we have a connection with external application server which want to get a location of user equipment device. So it requests that location gateway mobile location center. That mobile location center try to identify that request if it is possible and then send AMF such request, which is also responsible for security, for access management, even when it comes to positioning services. And AMF requests that information from location management function because location management functions has direct connection with new generation run with base stations via NAS interface, via NAS protocol. So location management functions is aware about any positioning measurements and calculations in the network and may provide that information through the AMF through gateway to external application server. Now let's talk about why 5G very suitable for positioning. Why only now finally we can talk about mature positioned cellular networks. First of all, 5G very flexible. We know that it is possible to use different subcarrier spacing with different slot duration. It means that measured in timing advance. Also, there are applications, massive antenna array, and as I said before, it is very good in terms of signal resolution. Beamforming may give us gain SNR, which is very good for accuracy and for latency of calculations. Large bandwidth is also very good comparing with previous technologies, because with the large bandwidth we may get bigger resolution in time domain. Operation with millimeter waves, it means that with more probability will be used massive antenna arrays not only at base station side but also at user equipment side. 5G also describe very interesting scenarios about device-to-device communications, about V2X communication. Positioning technologies may assist self-driving cars or any applications related to device which out of coverage. Also, we know that 5G usually operates in millimeter waves in C-band. It means that network becomes more and more densified. So it means that there is a higher probability that user equipment will work in line of sight, which is very good in terms of accuracy, in terms of resolution. And also 5G with virtualization techniques, with the more advanced processing techniques, also very suitable for artificial intelligence, for machine learning algorithm, which may help us enhance position even in very heavy non-line of sight scenarios. So let's try to figure out why 4G, 5G networks need new signal for positioning purposes. To be honest with you, I've never heard about positioning reference signals before, but I was really impressed that signal was introduced in release 10 in LTE. I think at that time there were not so many cases for positioning, for localization. That's why not so many of us even heard about that signal. But in 5G, in release 16, it was also introduced. And let's try to think for what purposes. The thing is that we already have a PSS, SSS signal, which is broadcasted in the network, and potentially they can be used for positioning cases. But they designed in a very specific way. They designed do not to interfere with each other, with neighbor cells, neighbor base stations. Cannot use them. We want to receive signals from multiple base stations, and that's why special signal is introduced, is PRS. In uplink, we can reuse sounding reference signals for that purposes. And as I said before, and very probably for user equipment with release 15, they do not support PRS-based positioning because that techniques was described in release 16 of 5G. Other devices, they may need measurement gap configuration. So I think it also should be taken into account. And if we look at this picture, we can see how within one resource block, 5G grid, that positioning signals from different transmission points or cells, we can say, they allocated. So they allocated in a very specific way, maybe very similar to 4G cell reference signal, but they designed in order to provide user equipment a capability to receive that signals from multiple cells, neighbor cells. 5G use beamforming, and that's why that signals should be designed in a very beam-centric manner. It means that it is possible to mute that signals in order to reduce interference level in downlink and increase probability for more accurate estimation. The transmission of PRS can be muted for different times for different cells. PRS may be allocated for the whole bandwidth, and they can use different subcarrier spacing. PRS transmitted with QPSK, and they organized in PRS sets. That PRS resource sets, they transmitted per each transmission point for each beam. And I think with the introduction of that signal, multiple questions can be raised. For example, how downlink PRS and how additional sending of sounding reference signals from user equipment can affect the performance, influence on interference level in the network, battery consumption, how transmitting PRS can influence on capacity in downlink, because some of resource elements they should be dedicated for transmitting that signal. I think this is also the questions that should be taken into account. Now let's talk about promising 5G use cases. Of course, this is obvious if we able to achieve pretty good accuracy and if we have beamforming techniques, so it is possible to perform position-based handovers or network procedures based on geolocation information from user equipment, which may increase reliability of the network. Also, we can apply position-based access and pricing. It means that specific access or pricing policy can be within a specific area. Cooperative positioning, for example, using side link, it means device-to-device technologies, or V2X cases, can be also very helpful in case of non-line of sight, out of coverage. And as I said before, with very accurate centimeter level positioning, it is possible to improve beam alignment. Very probably some scheduler techniques can be based on geolocation data. Also, it is possible to collect data from devices and use that data for further analysis in order to perform optimization, planning of your network, using not only radio measurements, not only measurements of throughput, latency, but also geolocation. Use maps, use it for self-optimized network features. So, as you see, multiple promising 5G use cases. Also, I want to briefly touch such topic as minimization of drive test 5G. I've already covered the top dedicated video. You can find that here. So, minimization of drive test. This is a kind of a feature of 4G and 5G networks. It allows operators to collect GPS satellite data with multiple radio metrics, with SNR level, RSRP, RSRQ signaling from real user equipment radio access network. Of course, it may give us an advantage because we may collect data from all places where satellite signals are available and use that data for further planning and optimization activities. Also, there are disadvantages because not all user equipments capable of that feature, or they may be not allowed by their chip vendor to use that, to send that geolocation measurements to the network. Also, of course, as any satellite-based technologies, it depends on weather conditions, it depends on satellites signals. Usually traces with that multiple measurements from millions of devices, they heavy weight. If you use some platforms for further analysis of that data, you should dimension that platform with high capacity, which requires a lot of hardware. And also, I would like to touch very basic security questions. First of all, if you collect data from user equipment in your network, you should think about, does it contain any personal identifiers? Does it contain any phone numbers, IMSI, IMEI, or GPS info coordinates? Do you need to update user consent, user agreement to satisfy your local regulations or company regulations? This is also can be a very tricky question. Also, you may think about, do you need to transfer that data abroad or different companies? It is legal in your case. It is allowed in your case. Also, some questions related to security, how long personal data kept can be processed, what delay, what kind of a retention period for that data, who is going to have access, who is going to administrator of that platform, who is going to manage databases, user interfaces of that platform. Because I think that basic questions very important, because if any extreme situation, any spoofing, for example, it may lead to unprecedented situations, not only reputation, but also lives and property of a company under the attack. I think that basic question should be also considered when you work with any geolocation data, when you work with any personal identifiers. And also, I would like to recommend for further investigation, of course, 3GPP standards. This is the initial source. Also, there is very good lectures and articles from one of the professor. You can find him in the internet. And a very good book, Location-Based Services in Cellular Networks from GSM to 5G NR. This is also my strong recommendations. So basically that's all for today. I hope you enjoyed this video about 5G positioning support overview. If you find that video very useful, you can like and subscribe to my channel, await new videos about 5G.